Hello there, this is Ricky Riggs once again, hopping into our first real progress video. I'm going to ignore all the stuff that you saw in the intro. We're going to start to build something like this from scratch, and it won't be exactly like this because I want you to really see it. That it could be very custom to your situation. We could just as easily build you know a different looking machine altogether. All these processes will apply. So what I'm going to do, I'm going to go ahead and just shut this down. I'm not going to reuse the logic here by copying it. I want you to see the total process. So that being said, let's close this down. No, I'm not going to save the changes on that. We still have that component, so I can just as easily drop it in, and there's my machine again. Um, so I'm not worried about losing my work, but I am more concerned with just showing the process on how to even get that going. So with that being said, we need to start with the machine design. I'm getting very abstract here, knowing that a three-axis machine is very basic, um, just in its design principles. So for simplicity's sake, we're going to start there, and I'm just going to draw that out. So I'm going to go ahead and minimize Grasshopper for now. Use what Rhino gives us. I'm going to go ahead and go into top view here. We're going to draw a rectangle. I'm just getting arbitrary with, what my shapes are. Get very abstract with that. And hopefully you see that from this abstraction, you could actually measure your machines and you can do these things however you feel you need to, for what fits your manufacturing processes and your shops and those things. So put up with me while I am being very abstract. Hopefully you can relate that directly to this could just as easily be your machine. We're going to go ahead and cap this, make it a solid, and might as well just copy that over. Have two rails, and now we can build a gantry bridge, a Z-plate with a spindle motor and a tool in it, and we can just get our machine designed in the CAD uh, normal design process for how we would draft or model anything. So go to the right view here, model the side of the gantry. I'll just use a polyline and I'll just freeform it. It doesn't have to be anything special. Okay, move that from there to there. We'll extrude that and put it there. Cap this guy, make it a solid, and copy that over. Make a rectangle. Oops, wrong plane. Get to the top plane. Cap that. And go to our front view just to change our working plane. Draw a rectangle. Let's say, I don't know, let's call it a shift at 1, comma, -1. Move that around. Extrude the curve. Yeah, something's not working right for me there. There we go. There's my object snap off. Just freeform it. Cap that. We'll get into a top view. Add a circle just to represent our spindle motor. And look straight at. Cap that. Bring it up to something that looks about right. Go to the bottom view. Draw, I don't know, a piece of tooling or something from the center of this. And ideally for something actual, when you actually get to your machine, you would draw in your collets and those kind of things because you would want to make sure that, you know, whatever actually sticks out doesn't crash into your material. Okay, delete the curve, cap the object. Okay, now we have all these solids. So that is step one. Step one, machine design. And we have it. You saw it from scratch. This is what we're going to use. I'm going to go ahead and end this video at this point. And next video, we're going to hop into how to connect all of this logic into the Grasshopper side of things, into all its different components and whatnot. And that's going to be what forms our definition. So catch me on the next one, and we'll start hopping into that.